Hey guys, I'm going to try this, try explaining some of these statics problems, work through them. Let me know if this helps you. I can do some more. So the first one I was going to do is 6-89. And so what it's asking for here is determine the horizontal and vertical components of force which pin C. So down here, there's a little pin inside these two joints, all pinning them together on member ABC. So the way to think about this is you have this member here, EDC, has a hole in the end, and ABC has a hole in the end, and there's a pin at C that pins them together, and it's saying the load is applied to the pin. And I just copied from the back of the book the answer just so we can double check that as we go along. Um, so one of the things to look at, if you look in your statics book, on, let's see what page it is. So it's 6.6 on page 305. It kind of gives you a breakdown. So when you have a machine like this, you want to create a free body diagram for the whole system to kind of find the reactions, kind of what you did before um, at point A and at point E, and then break it apart. So in each individual piece, so you'll have one for EDC, ABC, DBF, and actually in this case, we'll also have one for just the pin at C. We'll have a little free body diagram for that. Um, so let's just start with the overall. Free body diagram. So, oops, sorry. All right, so in this we'll just take, we're just drawing enough really to be able to calculate our reactions. So at E, the thing to notice is this is a fixed pivot, so that means it's going to have an X and a Y reaction. And at A, it's a rocker. So what that means, it's just going to have a reaction in the X direction, because the way the little symbol works basically is if you push this up or down, it rocks, it allows it to do it. So it means it's not over constrained and you can sign it. So we'll put these two in here, and we have our dimensions, our measurements here and here. So just the way I think about it is that since we have a pinned connection here at E, that's going to have an X and a Y. So we'll just call those force EX, force EY. At A, we're just going to have force AX, just because there's no Y component because of that rocker. And then we have the 300 Newton force here. And I'm not going to write out all the measurements, but so taking this, we just do sum our forces in the X, set them equal to 0. So, and I'm just picking everything in the positive X. I don't know. That's just the way I do it. Um, the worst case that'll happen, like I said, you get a negative somewhere and you realize you messed it up. So it's not a big deal. So let's sum all those up. We'll get the force EX plus force AX minus 300 newtons. Sum in the Y equals 0. You'll get force EY minus 600 newtons. And then taking the moment. I'll take the moment, let's say clockwise at E. That's going to be 0. So in this case, I'm picking E just because we have two unknowns going through it, and so that gets rid of it, and it'll help just let us solve for FAX. Going back to our measurements over here. So I just use right hand rule just to help me with the orientation here. So 600, that's, let's say that's 4 meters between here and here. So that moment is 4 times 600, and it's in, since we're picking clockwise, that's positive. And then the 300, if you look over here, where is that? That's 4.5 meters, and it's also in the clockwise direction. So plus 4.5 meters times 300. And then the going in the other direction, the counterclockwise direction, is force AX, which is so minus, and the distance there, looking back over there, is 3 meters. So if we solve that for, we get a calculator out, because I'm an engineer, I can't do math in my head. So I got 4 times 600 plus 4.5 times 300, and we get 50, and that goes on the other side because of the minus, and divided by 3. That's where we get 1250 newtons. So plug that back into the first one. We get FEX plus 1250 minus 300. So FEX is going to equal minus 950. Does that sound right? Yeah. And then just looking at that one, you can solve the y for FEY. It's going to be equal to 600 newtons. So that's kind of just gives us these reactions that it'll help us later when we break this thing apart. So that's our next step, break it apart. I guess you can do this different ways. The way I like to do it is to label each of these with just like a little number. So sorry guys if I ran that off the edge of the page. I'll do that for a second. So in this case, I'm just going to call this one here 1. I'll call the horizontal beam here 2. I'll call that guy 3. And we'll just call the pin P. So now we have to break all of these apart and do a free body on them all. So we'll have, so this is 1, point E, point D, point C. And so the convention here is when you're putting all of these things different free body diagrams of the individual things together. You can kind of really pick any convention you want for an X and Y component of the reactions at these. Just the thing you have to make sure about is when you pick the one it connects to, you pick the opposite direction. So I'll show you for a second. So let's just say we'll call this f of ex, f of ey, f of dx, f of dy. And if you were much smarter than me, you could probably figure out intuitively, what the actual direction of these things are, but engineers are naturally lazy, so I just like picking a convention I can stick with and just try to do the math correctly. So, got this one here. It's got A, B, C. Now, in this case, actually, even though this is point C on both of them, I'm going to actually change this and make that C1 and make this C2. And the reason for that is because they're not connected together directly in this case because we have that pin in between them. So I'll call it the pin. So we got this. And I think normally you can get away without doing this, except in this one case or actually they're saying, they're applying the load to the pin. So that makes things a little bit more challenging, or just a little bit different. So in this case, we'll have the pin has the 600 Newton load down that way. For the reaction load now has to be the opposite direction for C1. So, and they don't really give good detail on how this thing's actually connected. Like if you look over here, it shows it kind of like that. So if you looked at the end, is it a clevis or, whatever, but we're not going to make all those assumptions just now. It doesn't ask for it. So what we'll do is because that's going up, FC1, this here will be FC1Y. And then since it's positive in that direction, we'll have FC1X. And then we could pick the opposite way, but I'm just going to pick the same way. Maybe we'll get lucky. Let's see, FC2X, FC2Y. So same thing on here. We're going to have opposite. We need the opposite of that. So FC2X. That one's Y. Sorry. FC2X. And we know it's probably going to be wrong, just because they're both pointing in the same direction and there's no force in that way. So one of those is going to be opposite, but we'll deal with that later. And let's do the same here. FBX, FBY. And then in this case, because it's a rocker, we know there's only going to be FAX. If it was another type of joint that had a reaction in that direction, then you'd have to include it. But in this case, since it's a rocker, we can leave it there. And even though we know the value of it, I'm just throwing this in here just to get the equations out. All right. So next one is 3. So that's this one going down here. So here we have 300 newtons. And we got the pin here, which is B. And then we got the one up here in D. So now both of these exist on these other two. Okay. So we got to make sure that what we're using is the opposite. So let's take B. It's going to be, should have wrote on the other side so it's not so messy. Sorry about that. FBX here and FBY. So it's opposite of that. And then the same over here. Same thing. Should have wrote on the other side. FDX. And then since that's up, that's down. FDY. All right. So now you'll see we got the 4 different bodies that go with this, and that we'll be able to sum up each of these, sum up the forces in the X and the Y. Sorry, let me try to focus. That's better. All right. Sorry. So we can sum up all the forces in these. All right. So, and you'll see since we don't have too many that actually have forces on it, like 600 here and 300 here, and we know what that is and we know what those are, most of these are probably going to end up, like, should be able to cancel relatively easy. So let's just go through it. Let's see how ugly it gets. So let's do equations for one. And depending how bad it, we can always get a moment equation in here if we need another equation. I'm just going to do the x's and the y's first just to see what's what. All right, so this is just pretty straightforward. It's equal to 0. We have f(ex), which we actually know. I'll just write it like this. Okay, that's the x's there, and then the y's. So that's just all those. Try to write a 2. So for the pin, let me just write this the pin. So I was thinking of it. In this case, we have minus fc1x minus fc2x is equal to 0. And then we have minus fc1y minus fc2y minus 600. And I'll do 2. So summing in the x, so we have fax plus fbx plus fc2x. And the y, we don't have anything for a, but we have you'll start noticing like these ones that have like zeros and then just 2 terms. And if they have the same sign, they're just going to be like opposite of each other. But then for 3, so here I got minus f dx all right, so that's just all the the x and y's equation. So let's see, how many unknown do we have then? Should actually have thought of that before we started, but so let's say we got 1, 2, 3, 4, 5, 6. Those are the opposites. 7, 8, 9, 10, 11 looks like. So 11 unknowns. We're going to need right, and then we also already found 3. So we found these 3. So we have 8 left, and we have 8 equations here. So we might be able to solve for this. If not, maybe we can throw in a. I'm just looking to see if there's an easy moment equation. So like in 3, I would probably pick a moment equation just because of around D. And the reason I'm just picking that are, actually you could just pick it around B, because you see like Bx, Fby, and Fdy all go through this point. And so the only forces are this one and Fdx, the 300 and Fdx. And if we sum up with the moment around here, we can get Fdx, and it's actually even easier just because since this is halfway this way, it's halfway this way. So this is 1.5, so it's equal distance, so let's just write that out. So sum of the moments around point D, and let's take it clockwise. So actually we said B, didn't we? Let's make it B. So we'll get 1.5 times 300 to go that way, and then to go in the other direction, minus 1.5 FDX, and those equal 0. So that cancels out, and just FDX is going to equal 300. And then from that, you can look at FBX, right? So bring this equation down, and so you'll have minus 300 minus 300 is equal to FBX, which will equal minus 600. So that's getting us closer. We can take this one. So what was this? This was number 3. Bring number 2 down. We have FAX from up here. So 1250 plus FBX, which is minus 600, plus FC2X. So FC2X will equal 650 newtons. And that's actually what we were originally looking for. That's the reaction of the pin on ABC, right? So that was what we had up here. So found that. That's the first part of it. And then the other thing we were looking for was the y component of that. And so we can start looking at these y terms. So here, you'll just say so I'm just kind of what I'm doing right now is kind of looking at these y equations and figuring out, I'm going to need this guy here. So I have C1y, C1y, EY, dy, but here I have dy, dy, so I think I can kind of work this together. Let's take this one and we'll say f dy is equal to minus f by. And then look here, we'll have f by is equal to minus f c2y. So that means that f dy is just f c2y, right? So if we go into that equation, we know what ex is from here. So let's rewrite that one. We'll get minus 950 plus fdx, which we actually have from, oh wait, I don't want x, what am I doing? I want y. fey, sorry about that, is the 600. Sorry about that. I make mistakes during it. Fdy, which happens to be that, so plus fc2y, because we have that is equal to that, plus fc1y. And then we have this second equation here from our pin that has c2 and c1y in it, so we'll just write it underneath it, like aligning the term. So the 600 minus fc2y minus fc1y. Did I have that right? I think I screwed up somewhere. Let's see. Minus here. Here, I'm going to pause this for a second so I can figure out what I did wrong, so it'll make this 2-hour video. So I don't know what I did, to be honest with you. I'm trying to figure that one out. But I was looking back, and it actually makes sense to go look at 2 again and to put sum of the moments up around point B on 2. And if you think about there's FAX, FBX, FBY, FC2, they all go through point B. And so since the sum of the moment has to be equal 0, FC2Y has to be equal to 0 too. And then that would mean that FC1Y would be equal to have to be equal to minus 600. But I was hoping we'd end up with 2 equations here. There's probably a reason why not. I'm trying to think about it, but I couldn't figure it out. But anyway, you still get the answer here by summing the moments up around here. And since that's the only thing that can contribute to it and it has to equal 0, that's equal to 0. So that ends up being our answer. We're looking for the original question was down here, determine the horizontal and vertical components of the force which pin C exerts on member ABC. And so member ABC, we're looking for FC2X and FC2Y, and that's what we get here. FC2X is 650, FC2Y is 0, and then if we look, that was the answer given in the back of the book. So I hope that helped. I'll post this. If you guys have any questions, please let me know. And if this is helpful at all, I'll try to do some more of these if you want. And if not, I could also just post the equations here, but it might be easier if I walk through them because I can kind of give you my thoughts as I'm doing it, and even show you how I screwed up that thing. Still not sure about that one. I'll have to think about it some more, but that should be enough for now. Let me know if you have any questions. Bye.